Hey everyone, and welcome. If you're a support engineer, you've definitely been there. That moment when two systems are supposed to be talking and they just aren't. Well, today, we're going to untangle one of the most common knots in that mess, the difference between webhooks and API polling. This is something you absolutely need to know. Let's get into it.
Okay, the easiest way to wrap your head around this is with a simple analogy you already live with every day. Think of API polling like you're compulsively hitting refresh on your email inbox. You're constantly asking, anything new yet? How about now? Now? A webhook, on the other hand, is just like a push notification on your phone. The second an email arrives, your phone buzzes. The server tells you something happened. You don't have to ask. It's a poll versus a push.
All right, so let's rewind a bit and talk about the old way of doing things. Before we had these slick push notifications for everything, applications had no choice but to constantly check for updates. And that constant asking, well, that's the heart of API polling.
Now, this chart really breaks it down beautifully. With polling, you can see the direction is client to server. Your app is doing all the work, constantly asking the server for data at some set interval, every minute, every 30 seconds, whatever. It's a pull system. Compare that to a webhook. It's a push system. The server tells your client when an event happens. That means you get your data in near real time, and it's way, way more efficient with resources.
And this right here, this is the polling cycle in a nutshell. Step 1, your client asks the server, hey, got anything new for me? Step 2, the server looks around. Step 3, 9 times out of 10, or maybe 99 times out of 100, the server says, nope, nothing. Step 4, your client waits and then does it all over again. It's a loop, and it's mostly a loop of getting told no.
So this whole cycle boils down to two huge problems. First, you've got latency. I mean, what if something important happens right after your client asks? Well, you're not going to know about it until the next polling cycle. That's a built-in delay. And second, it is just so incredibly wasteful. All of those requests, they eat up bandwidth, they burn CPU cycles on both ends, and for what? Most of the time, they come back completely empty.
Let's put a real number on that wastefulness. Let's say you're polling every 30 seconds for an event, like a customer making a payment. And let's say that only happens 10 times in a day. You do the math, that's 2,880 requests you made. And out of those, a staggering 2,870 of them were completely useless. They found nothing. That's a lot of noise for a tiny bit of signal.
And all that inefficiency, all that waste, that's exactly why we needed something better. And that brings us to the modern solution, the elegant, event-driven power of webhooks.
So what exactly is a webhook? Well, the simplest way to think of it is as an automated message, an HTTP callback. You give a service, like GitHub or Stripe, a unique URL that you control. Then, when something interesting happens on their end, like someone pushes code or a payment goes through, their server sends a message, a data payload, straight to your URL. That's why people call it a reverse API. It completely flips the script on who starts the conversation.
So here's how that all plays out in practice. First, some event happens. Then the source system, let's say GitHub, bundles up all the info about that event into a nice JSON payload. Now this next step is absolutely critical. GitHub then signs that payload with a secret key. After that, it sends everything in an HTTP post request to the URL you gave it. And finally, your server gets the data, checks the signature, and does something with it.
Now that message it sends, it's really made of two parts. You've got the HTTP headers, which have little bits of metadata, like what type of event it is. And then you have the JSON body, which is where all the good stuff is, all the juicy details about what actually happened.
Okay, this all sounds perfect, right? It's real time, it's efficient, but there's a catch. And this is a big one, something every support engineer has to grapple with. It's all about security.
Seriously, think about it for a second. Your webhook endpoint is just a URL, hanging out there on the public internet. Anyone could send a post request to it. So how can your server possibly know that a request really came from GitHub and not from some bad actor pretending to be GitHub?
Well, the answer is some pretty clever cryptography using something called an HMAC signature. When you set up your webhook, you and the provider agree on a secret key. It's like a password only the two of you know. The provider uses this secret to create a unique signature or a hash of the payload, and they stick that signature in a request header. This is proof that the request is legit and that the data hasn't been messed with in transit.
The way this verification works is actually brilliant. The sender, like Stripe, calculates a signature using the payload and your secret.
They send it to you. Now, on your end, your server takes the raw payload it just received and performs the exact same calculation with its copy of the secret. Then it's just a simple comparison. Do the two signatures match? If they do, awesome, you can trust it. If they don't, you throw it out.
Now, with all this talk about cryptography and hashes and secrets, you might think most webhook failures are these super complex security issues. But here's the reality check, summed up perfectly in this quote. The vast majority of failures are not crypto problems. They're way more mundane. They're about how data is formatted, or if the server clocks are out of sync, or if there's an issue with a header or an environment variable.
And that brings us right to the front lines, the stuff you're actually going to see in support tickets when you're dealing with webhooks in the wild.
All right, issue number 1. This is the big one. By far the most common, most frustrating problem you'll ever encounter is a signature verification failure. You'll see it in your logs, 401 unauthorized, or invalid signature, and the delivery just fails over and over again.
So, why does it fail? Well, it could be a simple, honest mistake, like someone copied the test secret into the production environment. It happens. It could also be that your server's clock is way off from the sender's clock. But more often than not, it's something a little more subtle hiding in your code. And the number one cause, by a long shot, is something I like to call the middleware trap. See, most web frameworks have this helpful middleware that automatically takes an incoming JSON request and parses it into a clean object for you to use. But in doing so, it modifies the raw request body. It might pretty print it, change the white space, anything. And remember, if the raw body changes by even a single byte, the signature you calculate won't match. Verification has to happen on the raw, untouched request body.
Okay, next up is when the signature verification actually passes, but your server immediately responds with a 500 internal server error. When you see this, it's a huge clue. The problem isn't the webhook itself. The problem is on your end. Your application failed to process it.
A 500 error is basically your server shouting, "Help! Something broke over here!" Maybe your code just flat out crashed, maybe a database connection dropped, or a really common one, your processing logic took too long and timed out. A lot of services, like GitHub, expect you to respond within 10 seconds. So a 500 error means it's time to go check your server logs, not the sender's.
And finally, we have what might be the trickiest one to hunt down, the silent failure. The webhook provider says, hey, we sent it. We got a 200 OK back. Everything's great. But on your end, nothing happened. The user's account wasn't updated. The notification wasn't sent. Nothing.
When this happens, you've got to put on your detective hat. Are you sure your code is listening for the right event type? Maybe you're expecting a pull request event, but you're getting a push. Or maybe the payload structure changed, and your code is trying to access a field that isn't there anymore. My favorite cause, though, is an error that gets swallowed by a try-catch block and never logged. Without good logging, these silent failures are basically ghosts. So let's bring it all home. The next time you're staring at a failing webhook, what's the real culprit? Is it some incredibly complex flaw in the HMAC cryptographic algorithm? Or is it that your web framework just decided to add an extra space somewhere in the payload? The single most important takeaway is this. Always, always assume the failure is something simple and structural before you assume it's something complicated and cryptographic. Check the raw bytes, check the headers, and double-check that secret. Thanks so much for watching.